And I'll agree with just about everything that was said. And what I'll add to that is sensing, especially in 3 dimensions, in unstructured environments, has proved to be extremely expensive. And the traditional approach for addressing that, as Professor Roy mentioned, has been LiDAR, or laser range finding. Doing that in 2 dimensions the costs have come down considerably. In 3 dimensions, where you're trying to look in both range and in azimuth, it's been much of a challenge to bring those costs down, because there are far fewer applications that go beyond robotics for that kind of technology. Velodyne, for example, develops a LiDAR. It can be seen on Google's car. It itself is very expensive. It's more expensive, not only more expensive than any component on a car today, but it's probably more expensive than the car itself. So some of those costs are rapidly being attacked. There are also sensors such as the Kinect, which in some environments help that quite a bit, especially if you're looking at ranges that are reasonably close. But one challenge with the Kinect is when you take it outside and it becomes saturated by sunlight, it becomes a little bit more of a challenge to use the Kinect as a sensor. So sensing is certainly one of the biggest challenges. And then moving beyond sensing, we've heard about things like object recognition. Many of those are algorithmic technologies. And so once those are understood, the scalability of those is much cheaper, because you're dealing with software and algorithms.
But I would say that is still a big driver of the cost. So, modern airplanes, forget about unmanned airplanes, just regular airplanes, 80% of the development cost is now absolutely the software, even at the scale of multiple vehicles. So I would largely agree with everything everybody said, but really emphasize the software development costs and also batteries. I think that's exactly right, that for a lot of these things, the battery is the one component, hardware component, that just doesn't last very long. And so it's not the individual cost of the battery, it's the fact that you're replacing them every 200 sorties.
Very good, good. We have a question here in the center.
Trying to speak loud. I used to work for Kiva, and one question we always had, the question was asked like 10 years ago. Humans are really good at identifying objects of all kinds of, weight, size, surface material, and pick them up, right? Robots couldn't do that. That's why the Kiva technology kind of sidesteps that. But 10 years from the founding of the company, I want to ask the kind of same question. How closer are we to solving that problem?